Yeah. Now let us look into a problem how to find out the resultant of a coplanar concurrent force system. So through a problem, we'll try to learn this. Now in figure here, there is a coplanar concurrent force system given like the previous example that we discussed. So there are four forces. One force 200 newtons making an angle of 30 degrees with the horizontal. Another force 500 newtons making 35 degrees with the horizontal. 750 newton force making 60 degrees with the horizontal. 150 newton force making 20 degrees with the vertical or y axis. But since we have we have a procedure of calculating the angle made by the force with the x-axis. So in this case we need the complementary angle which is missing here. So let us first look into that. So definitely this angle will be 75 degrees. So now our job is to get the resultant of these four coplanar concurrent forces. So since there are more than two forces, we have to go with method of resolution. So each force represented in the force system has to be resolved into its x component and y components. We have to algebraically add all the x components and algebraically add all the y components. That we will start with. Let R be the resultant of the given force system. So next, and alpha be the angle made by the resultant with the x-axis. So we know the equations to get the magnitude of the resultant, which is nothing but R is equal to under root sigma fx square plus sigma fy square, and alpha the angle made by the resultant with the x-axis, which is given as alpha is equal to tan inverse of sigma fx y by sigma fx. So we have to look into calculating sigma fx and sigma fy first. So now sigma fx, the equation will be in term as sigma fx is nothing but fx1 plus fx2 plus fx3 plus fx4, because we have four forces. Fx1 represents the x component of the first force, which I take it as 200 newtons. Then in the order, similarly sigma fy is nothing but the algebraic sum of all the y components of the four forces. So now sign convention, which we should not forget. We in this situation, a horizontal force to the right I take it as positive, a horizontal force to the left I take it as negative, a vertically upward force I take it as positive, a vertically downward force I take it as negative. So with this, let us start resolving each force and then start calculating sigma fx and sigma fy. Sigma fx. So 200 newton force, its x component is to the right, so this goes with a positive sign, which is nothing but 200 cos 30, angle with the x-axis always. Now 500 newton force next, its x component is also to the right, so it is positive, plus 500 cos 35. But coming to this 750 newton force, its x component is to the left, so it goes with minus 750 cos 60, angle with the x direction. And lastly 150 newton force, its x component is to the left, so it is again minus 150 cos 70. Now using your calculator, when we simplify this step, we get sigma fx is equal to 156.48 newtons. That means it is going with a positive sign, means the sum of all the x components is to the right. So that means sigma fx is a single force acting to the right now. Now we also need sigma fy also for the other calculations. So let us start with sigma fy. Now first force in the same order, 200 newton force, its y component is upward. 500 newton force, its y component is downward. 750 newton force, its y component is downward. 150 newton force, its y component is upward. With that, if you start 200 sine 30 now, because y components sine 30, because we are always measuring the angle made by the force with the x-axis. The function for the trigonometric function to calculate the y components, we know it is f sine theta. In the same manner, minus 500 sine 35, y component is downward. Minus 750 sine 60, y component is downward. Plus 150 sine 70. So we have measured the angles made by all the forces with the x-axis only. So for x components cos, for y components sine. Now again using the calculator, when we simplify, we get sigma fy is equal to, in the calculator, and we have that it is a negative sign, that means sigma Fi is now a single force in the y direction, which will be downward. Now the four forces which were given have been reduced to two forces, sigma Fx and sigma Fy. Sigma Xfx is one single force in the x direction, sigma Fy is one single force in the y direction, but it is downward. Now let us represent these two as the adjacent sets of the parallelogram to get the resultant of sigma Fx and sigma Fy, which will also be the resultant of all the four forces. So sigma Fx, sigma Fy. We are following the sign convention with this. Now complete the parallelogram with these two as adjacent sides, and this is the point of origin or point of application of all the forces. Through this point, mark the diagonal, which is nothing but the resultant, and the angle made by the resultant with the horizontal or x direction is nothing but alpha. So we already have the equations to find out sigma Fx and sigma Fy. So on mere substitution, and simplification using the calculator, we get R value as 712.75 newtons, and alpha will be tan inverse of, but please be careful, sigma Fy by sigma Fx. But here negative sign can be avoided, or you can go with absolute value, because we have marked resultant in its proper direction. So absolute value for alpha is okay, and we get alpha is equal to 77.32 degrees. So this is the procedure to calculate the resultant of a co-planar concurrent force system. But please understand that even if the angle made by the force with the y-axis is given, immediately calculate the complementary angle in such situations, and a simple procedure, we get the resultant, its magnitude and direction.